Well, this is John Black, Super Chemist. We're going to here talk about what pi is. Our main objective is because my next video is going to be about the inverse square law that deals with, how gravity loses its power the further away you get away from the gravity source. Pi is a number, okay, just like dozen is 12. It's just a number, and it's 3.1416. Now, what is it though? Most definitions will tell you that pi is a ratio of the circumference and the diameter. Okay, so what does that mean? That means the circumference and the diameter are equal right here, C equals D. But they're not really equal. They need a multiplier. They need a conversion factor. And pi is the conversion factor. So D times 3 is C, right? So D is, that just means the circumference is 3.14 times bigger than the diameter, right? But I want you to see. So what does that mean? That means 3.1416 of this diameter, right? That's what it is. You got one diameter, two diameters, three diameters, and a 0.116 diameter. This line equals this line. See, equals this circumference line. These two lines are equal in length. That's all pi means, okay? But it also means, it's a ratio for a bunch of stuff, okay? When it comes to circles and spheres. And we'll move into our next example, right? What's the area of a two-dimensional circle? Right here, r squared times pi. But what does pi mean in this respect? Pi means, and that's why there's never any units on pi, right? Like up here, we're talking about a line and we're talking about a line. Both are lengths, right? Like feet or, miles or whatever. Same way down here. Pi is a ratio of the area, right, of the circle compared to the area of this square. Where did this square come from? Well, you take any circle and you draw a square around it so that you're touching the square at these 4 points, right? Then you can make a checkerboard, right? A plus sign there. This square is and this is the radius of the circle, right? And this is the radius of the circle. So this is a square. So this times this tells you the square footage or square, whatever, of this square. And all it's saying is if you take this square, right, and you get 3.1416 pieces of it, this area of all these squares will equal this area of this circle. It's a ratio, just like up here, it's a ratio, 3.14 to 1 circumference. 3.14 of these squares to this whole circle. The areas are equal, okay? It's a ratio. Pi is a ratio, and that's why it doesn't have any units. These are, area units and area units, distance unit and distance unit. They're the same units, so they cancel out. Now, what's this next thing, 0.785? That's another ratio that's kind of like pi. What is it? It's actually 1/4 of pi, okay? So what does that mean? Okay. I messed up. This fraction should look like that. This ratio should look like that. This is because these two parts add up to a square. You can see if I put them together, it's a square, right? This is 85. This is 78.5% of the square, and this is the rest of it. Same over here. There's a ratio. This, notice how you did the circle and then you put a square inside it. This is that square, and then this is the circle. Where this circle and this square have a ratio of 0.785, meaning that if I take this area and this area, that this area is 0.785% or 78.5% of this, okay? They're a ratio. Okay? Basically, if I take 0.785 times 4, it will equal pi. This number is 1/4 of pi. And you can use it. This is actually, I don't know why they don't give it a number, this number. It can be used just as good as pi almost in 25% of the situations. Say you have a circle You don't know the pi. You don't know the first step. Draw a square around it where they only intersect at these 4 points, right? Then measure the distance. Measure the line here. Here on mine, I have 1, 2, 3 units, or 3 feet. 3 times 3, that means this area of this square is 9 feet, square feet. I take that times my John Black constant of 0.785. It gives me 7.065 square feet. This is the area of this circle without using pi or trying to measure this circumference. Yeah, I'm just going to call this the John Black constant, 0.785, because I've never heard anyone no one's ever brought that constant up to me. I don't know. I just remember that from as a kid, but nobody actually told me that constant. There has to be a name for that constant. Somebody tell me. So let's move on to the next one, the last thing here, because we did the 1 dimension, then we did the 2 dimensions. Let's do the 3 dimensions. Okay, now we're going down to a sphere, right? Going down to 3 dimensions, right? We're still going to use 2-dimensional stuff, right? What is the formula or equation for the, to get the area of a sphere, the surface? You're like, oh, a sphere is 3D. No, we're talking about the surface. The area of the surface is equal to 4 r squared pi. See, this r squared pi, that's the area of a circle that's 2D, right? So anyways, what's the ratio here? Here the ratio is, so this is the surface area of the 3D sphere, right? All they're saying is the area of this surface of this 3D sphere is equal to, right, 3.1 of these 4r square things, because each one of these is a 4r square, right? 4r square, 4r square. Well, these 2-dimensional shapes here that we know how we got, right? If I took all that area is equal to the surface area of this 3D ball. Okay. Then, right, look down at the last equation, right? Now remember up here we said r squared pi is the area of a 2-dimensional circle, right? R squared pi. So 4 r squared pi's would be equals the surface area of a 3D circle, right? So that's what this is saying down here, right? You replace the r squared pi, right, by area of a circle, right? And that's what we did. We took out the r squared pi and we put in area of a circle times 4, right? Because there's a 4 there. So what does that mean? That means if you just like a cube or a dice, right? A dice or a box has 6 sides. A 3D sphere has 4 sides. A sphere has 4 sides. Okay, and you might say, what? Here's a sphere, this red part. If you can, and these are the black part are 2D circles. You can see that one goes up and one kind of would be like flat, and this one is like that, and this one is like that, and that one's like that. Those are your 4 sides. Obviously, there are no sides to a circle. This whole video is just showing you how I look at pi and how I look at things. Okay. If you want visualization, that's how I visualize it. There's 4 sides to a sphere, and these are the sides. See this square right here? This is one side of a sphere. Remember how we said this little square here is times that by pi, and you'll get the area of this circle, this 2D circle. How do you get the 3D surface area? You multiply by 4. There's 4 sides to a sphere. 1, 2, 3, 4, right? So you just multiply this into this. 1, 2, 3, 4. See how it has 4 sides? Now, 4 of these times pi is the surface area of the 3D sphere. See how there's 4 sides? Not really, but it's just a nice way to, it's an analogy. The area of these 4 circles, 2D circles, is equal to, right? Equal to the surface area of this 3D sphere. Now if I have, this is 3.14, right? These 1, 2, 3, and then 0.14, right? This is 4 circles. 1, 2, 3, 4. They come. The circle comes from here, and the square comes from here, right? The ratio of this and this is 0.785, right? If I take 3.14, right, which is this, 3.14, and I divide by 4, right? So the 4 is going into the 3.14. That equals 0.785. Just like up here, right? There was a ratio of, the square, 78.5% of this square is here, right? Same here. It's a ratio. The area of the square, this area of this circle here inside the square, that circle, 0.5% of the area of the whole square, right? That's a ratio, right? That's why they have this 4. Pi equals 4 times 0.785. That's where the 4 comes in. See how that 0.785, maybe that does. If anyone knows, does that have is that considered a constant like pi or like, 0.785? I've never heard anyone ever use that except for me. But what do I know? It's not like I sit around and talk about math with everybody, people all day. Let's go into the last thing here, right? Because this is the part I want you to, we're going to go into the inverse square law, right, for gravity. If a sphere radius, right, you have this 3D thing here. If the radius doubles, right, that makes the 3D ball bigger, right? If you make the diameter bigger, you're going to make the ball bigger, right? Well, if you double the radius, then the surface area of that 3D ball is going to multiply by 4. Okay, and this kind of goes into the inverse square law, and we'll get into that in the next video. But I want you to understand how these, this pi thing is just a ratio. Okay, it's a ratio because things are equal to each other, but they need a conversion factor, right? And it's basically just a conversion factor, right? Circumference and diameter are equal, but they're off by 3.14. So you need this multiplier. Same down here. The area of a circle and the area of this square here, right? And that the area of the circle and the area of the square here, they're equal. They're equal. Well, they're equal, but they need this conversion factor. Same way with down here, right? Pi is a ratio of the area of the sphere surface, right? A ratio of that area to the area of this big giant square here, okay? And the ratio is these big square. You can see the ratio. You can see the ratio up here. I'm putting it. Here's the ratio here. You know what I mean? Down here, here's the ratio. It's 3.14 to 1, right? But again, I want you to see that the area of the surface of the 3D ball is equal to one of these areas of these squares. Almost. You just need a conversion factor. It's actually, you need to multiply it by 3.14. See here, the area of surface of the sphere is more than the surface, than the, on a 2D circle, right? So you have to multiply it by 4, right? Up here, the area is r squared pi. Down here is r squared times pi times 4, right? Because it's a sphere, you got more surface area, right? But all they're saying, right, is there's a ratio between these 4 2D circles and the surface area of this 3D thing. There's a 4 of these equals the surface area of this, and this surface area equals 3.14 of these, right? And 3.14 of these equals 4 of these, right? They're a ratio of 0.785. Anyways, science is great. So have a great day.